So this question, it's a linear approximation question. Go ahead and read it. They give us the measurement of an edge. The edge of a cube is supposed to be 5 centimeters with a possible error of 0.2 centimeters. Use linear approximation or equivalent method to estimate the possible volume with an edge length of 5.2. I'm using V equals E cubed. That's E for edge length, not E as in E to the X. And then the next one asks us the same thing, but with surface area and an edge length of 4.8. So let's do part A first. I'm gonna take the volume equals E cubed. I'm gonna find the volume at side length of 5. So V of 5 is equal to 5 cubed, which is 125. I want to do y minus y1 equals m times x minus x1. You could use e's and v's, but I think it's easier to stick with x's and y's because that's what we're used to with tangent lines. So this e cubed right here, this 125 right here is going to become the y1. So I'm going to write y minus 125 equals. And now I got to go x minus, and I'm going to take that x value that edge value that gave me the 125. So I'm going to get a 5 in there. So I'm going to get x minus 5. All I have to do now is find out the slope. So to find out my m, I just do v prime. And that is 3e squared. It's just power rule. And then I'm going to plug in my 5. So v prime of 5 is, 3 times 5 squared. That gives me 3 times 25, which is which is 75. That looks better. So that just becomes the m. So I'm going to write my 75 here. Now, if you notice, we want to, that was using the starting side length. I want to estimate at 5.2. So that means I just plug 5.2 in for x. So I get y minus 125 equals 75 times 5.2 minus 5. And then we'll go ahead and do some math. I'm going to move the 125 over. It becomes positive. Equals 75 times 0.2. So there's a couple ways to do this. I like to move the decimal and hold on one moment. There we go. That should be a plus. So I got to add those. So I like to move those decimals and do the operation 7.5 times 2 because that's easier than 75 times 0.2. And that gives me 15. So I get y equals 125 plus 15, which gives me 140 centimeters. And that's my answer for part A. And I guess in a moment I'll go and I'll show you how to do B. So B is very similar. Instead of volume, I'm going to use S for surface area, and that is 6e squared. I'm going to follow the same mechanics here. I'm going to go S, whoops. All right, so I'm going to find S of 5, which is 6 times 5 squared, which gives me 150. From there, I'm going to write y minus y1 equals m times x minus x1. And I'm going to plug in what I know. So I know I've got y minus 150 equals blank times x minus 5, because those are the two values that I have there. And now I got to find the m. So to find m, I'm going to go s prime equals, I get 12e. That's just, again, power rule. And then I'm going to find s prime of 5. So I get 12 times 5, which is 60. So from there, I get an m of 60. And again, I need to go ahead and plug in the value that they gave me. So they asked me to do it for this value right here. So I'm going to plug in 4.8. I get y equals 150. I'm going to move that 150 over. plus 60 times 4.8 minus 5. Notice that gives me 150 plus 60 times negative 0.2. And I'm going to do the same math here again. I'm going to take this decimal and move it once, and this decimal and move it once. So really, I'm just doing 6 times 2. That's the same as 60 times 0.2. So I get 150, and then don't forget the negative, minus 12, which winds up giving me 138. I should add my units. This is centimeters squared. And then I didn't write cubed up here. It should have been cubed. So there you go. That's how we do part B. The one comment I want to make here about this is that it says or an equivalent method. So what I've walked through here is using linear approximation. I have a function. I have a value. I plug something into it, or I figure out a tangent line for it, and then I plug something into that tangent line, and I get a number at the end. Differentials is another equivalent method, and there's a variety of other things that will do this same math and get us to the same answer. I just sort of think that doing it as a linear approximation is the easiest way, most familiar to us, I guess. So, but it's different for different people. So you might like differentials better, and if that's what you want to use and you can show the math, that's great. So thanks, and see you in the next video.